Let me introduce myself. I am Arshad, a senior physics faculty, Pondicherry, an academy, and who are there nearby this city. You can visit our center and get the offline classes. Those who are not from here, they can watch and they can get benefited from these YouTube videos, and definitely these are free of cost. Yeah, 100% content you will not find here, but definitely it is going to help you in your journey and it is going to help you a lot. So stay tuned, watch this video, and if you like this video, share with your friend, and it will help you, and I'm going to take you to the level where you will feel physics is never difficult. The right person was missing. Thank you. Stay tuned. See you tomorrow. Thank you. Hello, hi guys. Hope you are all are enjoying the videos, and uh, hope you are solving the questions also. And I'm going to solve a lot of questions because these are basic mathematics. So these are itself a question. So when I'm going to use in physics, I'll help. It is going to helpful so much there. So now let's discuss slope intercept form, and we discussed this. Yes, in last videos we discussed straight line. In straight line we discussed slope intercept form and intercept form. These two equations of a straight line we discussed. Then we discussed circle, then we discussed parabola, the different forms of parabola, and we discussed rectangular hyperbola, how it appears and how it look like and what is the equation. And then we discussed hyperboloid, and then we discussed ellipse, and then we discussed hyperbola, and then we discussed sine curves and cosine curves, and then exponential curves and logarithmic curves. So these are the things we discuss and which are important, sir. You should go through once again this fifth part of the basic mathematics. And now today's video I'm going to discuss differentiation, which is very commonly you means taught by the teachers, and as well as I'm going to teach it obviously because of the wide range of application of it in physics, right? So you will enjoy this, and definitely, and hope you will listen the video carefully and sit tight. Let's start differentiation. So now, so give the heading differentiation. Sir, differentiation is also known as derivative, right? So this, what is this, sir? Why we are naming this differentiation and derivative? Let's talk about it, and then let me introduce little bit, because this is obviously for NEET student, this is first time and this will be the last time, because if they are not going to study in maths, they will use it in physics only, that's it. So that's why for NEET student they should focus more, and for JEE obviously they are going to study it in class 11th maths in detail more than today's video also. So obviously I'm not going to teach in that depth, but yeah, whatever extent we are going to use in maths, we are going to use in physics, I'm going to discuss all those extent, sir. Now let's start with this concept, that is differentiation. So now, sir, what is differentiation? Let me discuss, sir. Sir, if I'm asking you to divide uh, your pen into smallest piece, which you can do, sir, you will say atomic level, but you can't do, no, you can't divide it into atomic level. Whichever extent you can divide into that much small length, let's say these are divided into small, which we can do. Let's say this, the thickness of this smallest part, we are the length is, let's say, L. This smallest part I'm saying dl. This dl is called differentiated part. Which part? Differentiated part. Means why we are using this d means it's differentiated, means the smallest part which up to which, or up to the level of extent we can go, means we can divide, further we can't do. That's why we are writing dl, means it is just about to 0, means this dl length is tending to 0, sir. Here I'll discuss what is this and why we are discussing this. So now let me make you more clear, sir. If I'm asking you because I'm going to teach in detail everything. So here understand one more thing, let me discuss. Sir, if I'm asking what is the area of this rectangle, you will just simply say, sir, if it is length and it is breadth, you will say, sir, area is length into breadth. If I'm asking area of a rectangle, if area of a square, you will say, sir, side is square. Area of, let's say, triangle, so you will say half into base into height. But what about the area of this curve, sir? Can you let me know? If I'm asking what is this area, how you will answer me? Even you don't have the formula. So to calculate this type of area, we will have to follow some procedure, sir. What is this procedure? I'll divide it into smaller pieces. What I will do? I'll divide it into smaller pieces. Smaller pieces means, sir, what should be the thickness? Thickness as much small you can divide. So I'm talking about this small thickness is dx. This is called differentiated form of x. Understood? So you hope you understood. Sir, why we are discussing like this? Sir, if you know this thickness, it is looking like rectangle, right? Small pieces are looking like rectangle. So you can apply the formula of rectangle, and you can integrate. Integrate means addition. When you will add small pieces, you will get the total area of this part, sir. Sir, again addition part I'm going to discuss in integration. Here I'm going to discuss the differentiated part, means small part of it. Why we needed small part here? Because of this, sir. You hope you understood why we need differentiation. If you are not differentiating, we can't go to the small section of this part. Smallest part is this differentiated part. Understood? Oh, hope you understood. Now let's me discuss the derivatives of few functions, right? So we can say it's derivative formulas, or you can say derivative of few functions. So what are these? Let me discuss. So you can say formula also, formula of differentiation, or in terms of differentiation, or derivatives of few functions. Actually these are derivatives, but you can remember in terms of formula also. Okay, so what is this? Let me discuss, sir. Sir, first formula you should remember is very important. Whatever formula I'm discussing, please note it properly. Sit with a proper pen and notebook so that you can copy down, pause the video, make a proper note and revise this, because widely I'm going to use in physics. So it's my request to you, please copy down. I'm going to use it and I will ask at that time. At that time you won't be able to answer if you are not going through, because this is first time you are studying. So make a proper note, sir. First is differentiation of x power n with respect to x. If you have a function x power n, if you are differentiating that with respect to x, means I'm making it smaller pieces of x power n. So it will look like n x n minus 1. The difference means you should keep, sir, how we are getting this? You should not ask it. Why? Because in differentiation we are going to use it in, sorry, we in mathematics we are going to give you the proof of it, but in here if I'm going to go with the proof, it is going to extend the video so much, so it's not use even, it's not useful in physics. So what is the useful in physics? To understand this formula and to keep in mind, that's it. Dx to the power n is nx n power minus 1, right? Second formula is, if I'm writing differentiation of x with respect to x, sir, x power is how much here? 1. So what will be the formula, sir? 1 x power 1 minus 1 0, so that is 1, sir. Okay, keep in mind dx by dx is 1. Third formula is, sir, if I'm writing differentiation of a constant c with respect to x, sir, constant, what is constant, sir? How we will understand it is constant or no? Sir, if the function do not depend on x, so entire function is constant. Sir, wherever x is not present, that is called function. Let's say a, differentiation of a with respect to x 0. differentiation of b with respect to x 0, differentiation of 1000 with respect to x 0, means anything which is not linked with x, which is not having x, will be a constant, right? Examples we will discuss, but formulas I am discussing. Differentiation of a constant with respect to x is going to be 0. Fourth formula, I am writing this side also. Fourth formula is differentiation of, sir, you might have, what is ln, you hope you understand this, right? Because I already had discussed what is the logarithm. In log base e, we are seeing ln, log base 10 we will say log, right? So here differentiation of ln x with respect to x is going to be 1 by x, right? So next is fifth, differentiation of e to the power x with respect to x is going to be e to the power x. This is the function whose differentiation is same as it is, no changes. Sixth, so differentiation of a to the power x with respect to x is nothing, a to the power x ln a, sir, right? You should keep in mind, sir. Next is, this is sixth. Seventh, I'm making table of it, so keep in mind. Seventh, so differentiation of sine x with respect to x, it's cos x. Eighth, differentiation of cos x with respect to x is minus sin x. Sir, one trick I am saying, whenever you are finding in differentiation only, the function is starting with c, sir, cos is starting with c, so the function will come with negative sign, so minus sin x. Next is wait a second, ninth, differentiation of tan x with respect to x, it's going to be sec square x, right? Similarly, 10th, differentiation of what, sir? Differentiation of I am discussing sec x with respect to x, it's going to be sec x into tan x. Sir, similarly, differentiation of cosec x with respect to x, it's going to be, sir, it starts with c, so it will be minus cosec x into cot x. Similarly, differentiation of 12th, differentiation of, wait a second, sir, now it is visible to you, differentiation of cot x with respect to x, it's going to be, again it starts with c, so it will be minus of cosec square x. Hope you understood, right? Now, sir, these are the differential formulas, you should keep 12 formulas, you should keep in mind, and these are going to be very much helpful in your physics, sir, because if you don't know these derivatives, physics is going to be literally difficult for you, because physics involved so many times these functions, right? Next, we are going to discuss the rules of differentiation. What are the rules of differentiation? Let's discuss this. Rules of derivatives or differentiation. So what are the rules? First rule, sir, very important rules. Without these rules, literally, if you know also how to differentiate, what are the formulas of differentiation, but you can't, you will do mistake. So you should know the rules, because these what I'm discussing here, basics. Basic means you should know each and everything here, right? Let's talk about rule. Rule number one. Rule number one says that if you have a function which is involving x and involving a constant also, let me discuss. Let's say if you have a function f of x and that is connected with k,
with respect to x you want to differentiate. So that constant k will come out first, then do the differentiation of x with respect to x. Sir, f of x is nothing, I am writing here, let y is equal to f of x. Sir, it is y actually, right? So don't get confused, f of x is a new thing, it's a function of x. Obviously if you will put x you will get y na, so that's why y is equal to function of x, right? Keep in mind. Next, you can write like this also, na, k dy by dx, because f of x is y. Wait a second, let me drink water. Okay, let's start. Sir, second rule, rule number 2. What is rule number 2, sir? Sir, rule number 2 says that if you have two functions, again I told function is nothing, it's y values. Sir, if you have two functions, differentiation of f(x) plus minus g of x, means two functions are in addition form. Then if you want to differentiate, so you will have to differentiate separately, sir. So differentiation of f of x with respect to x plus or minus, whatever it is there, you will put as it is, and then differentiation of g of x with respect to x. Sir, application I'm going to discuss, not to worry. Okay, let me discuss the application also. Wait a second. Example. Sir, example I'm giving here. If I'm talking about example, if you have differentiation of 2x square with respect to x, how will differentiate, sir? Sir, I told you from the above formula or rule, 2 should come out because 2 is a constant, so 2 came out. Differentiation of x square by dx. So what is this formula I'm going to apply here? X power n. So what is this? 2 into x power how much, sir? 2. So it is going to be x power n, differentiation is how much, sir? Come here, x n power minus 1. Can you see it? Yes. So now let's use it. X power nx. N is what, sir? 2. Wait a second. N is 2 into x power 2 minus 1, it is 1, so it is 4x. So 4x is the differentiated part of, after differentiation what I am getting, 4x is the answer of 2x square. Similarly, if I am taking example here also, can I take example here? Yes. So what is the example, sir? Here differentiation of, let's say you have x power 3 minus 2x, like this, with respect to x. How will differentiate, sir? Sir, first you will differentiate x cube, then minus and differentiation of 2x with respect to x, sir. Right. Now here separately you need to differentiate and then you can answer. Sir, here x power 3 means x power n formula. So n x n minus 1 minus, here 2 is constant, will come out. Dx by dx is how much, sir? 1. So you can write like this, 3x square minus 2. 2 into 1 is 2. So here it is square, sir. Keep in mind, minus 2. So this is the answer, sir. Similar, isn't it easy? Actually differentiation is easy if you understand the process rules. Okay. Next is third, rule number third. So rule number third says that if you have two functions in differentiation, sorry, multiplication, sorry, my mistake, they are multiplied to each other, then how to write the differentiation formula? Rule says that first, keep in mind, this is very important, I'm again keep second function, that is gx, as it is. Now differentiate first function, differentiation of fx with respect to x plus, sir, because it is multiplied, so I will write plus in between. Now you keep as it is f of x. Now you differentiate g of x, second function, with respect to x. This is the rule, sir. Sir, application. Sir, this is also known. See, f of x, I am saying one thing, more thing you should keep in. If I am saying f of x y, sometime it is also u. Now g of x I am saying v, sir. Okay. Wait a second. This is f of x, I am saying u, and g of x v. These are just symbol, don't get confused. Sir, f of x, you are writing y, you are writing u, just names for your understanding. Because if I will write same name, you won't be able to understand f of x, g of x. If I am writing f of x into f of x, so you will square it and you will lose, because all the time function won't be same, function will be different. So name it differently, na. It will look like same, but obviously sir, slightly difference will be there, so you'll have to follow the rules. So this is, now can you write this same expression I'm writing, or in books also somewhere you will find like this, differentiation of u into v form. No problem, sir. V as it is, differentiation of u with respect to x plus u differentiation of v with respect to x. This is the rule, sir. So it is looking easier na in terms of u and v, because it's to write f of x, g of x, complicated. But uv is very simple to understand. So you can go with uv also. Now let me give you example, sir. Sir, if I'm talking about example of it, so differentiation of, let's say, e to the power x into x. This is the differentiation the question is given. Now can you solve it easily? Yes, easily. How? Sir, what I said, keep v as it is, differentiation of u with respect to x, plus v as it is, differentiation of u, sorry, v, u as it is, differentiation of v. V means x. Now what is the answer, sir? X e to the power, sir, differentiation of e to the power x is e to the power x, plus e to the power x as it is, differentiation of x is 1. So answer is x plus 1 into ex, sir. This is the answer, sir. Ex common. Okay, so it's, isn't it easy? Again easy, sir. You should follow the rule, that's it. Fourth, rule number fourth, and that is the last rule, or chain rule. One more rule is there, fifth also I will discuss. So rule number fourth, sir. Rule number fourth. Rule number fourth says that if you have differentiation of f of x with respect to g of x, again you can write, if you want to write, you can write, or differentiation of u and v. I will write both, not to worry. Differentiation of f of x with by g of x with respect to x. I want to differentiate these two functions with respect to x, and they are divided form, right? So let me write this. First, again rule is same, g of x as it is, differentiation of f of x, minus here, because they are in division form, so I will write minus. Sir, f of x as it is, differentiation of g of x, divided by, here divided by g of x whole square. This is the extra thing you should add here. Now let me write in terms of uv. It is going to be very much simpler. Wait a second. Sir, differentiation of u by v form. What is this, sir? Keep v as it is, differentiation of u with respect to x, minus u as it is, differentiation of v with respect to x, divided by v square. Isn't it easy? Easy. Denominator will be square of the v, sir. Okay, this is, you should keep in mind. This is the rule, sir. Now example, sir. If I am talking about example, understand the example, sir. Same example I am taking, differentiation of, let's say, e to the power x by x you have with respect to x you want. Sir, you can write like this. V as it is, differentiation of e to the power x with respect to x, minus e to the power x as it is, differentiation of x with respect to x, divided by x square, v square. So what is this, sir? X e to the power x is e to the power x, minus e to the power x, differentiation of x with respect to x is 1, isn't it? Divided by x square. So what is the answer, sir? The answer came out x minus 1 e to the power x divided by x square. Further simplification you can do as per the requirement of the options. You can go with this. Got it? Up to hope you might have understood it, and there should not be any confusion. If there is any confusion, please let me know in the comment box, and definitely I'll get back to you with the explanation, and it is going to help you a lot. Next. Next is I am going to discuss see rule number fourth done. Now rule number fifth. Rule number fifth says that this is called chain rule also, right? You should keep in mind chain rule. Chain rule. Most common rule, sir. What is chain rule, sir? Sir, chain rule says that I am discussing here chain rule. Chain rule says that if you have a function of function, function of function, sir, f of g of x means this is called function of function. How to write the differentiation form of it? Sir, first you will differentiate f of g of x with respect to g of x, sir. Then you will multiply again, because you are not, your intention is not to the differentiation of the function with respect to gx. Your intention is to the differentiate the function with respect to x. So I didn't do this. So I will have to do differentiation of g of x again, because g of x extra I do. So I will have to here dx. Now this is the rule, sir. Sir, you will say, sir, I didn't understand. Can you explain? Yes. Let me take example, then you will understand more clearly. Sir, example is I want to differentiate, let's say, sine e to the power x with respect to x. I want to do differentiation of sine e to the power x with respect to x. How to do this? Isn't it a function of function? Yes. Sine is a function and inside e to the power x itself a function. So can we do like this? Differentiation of sine e to the power x with respect to, sir, I need to do differentiation. See, if it is sine x with respect to x, I could have write sine cos x, but sine x is not present, sine e to the power x is present. So I will have to differentiate sine with respect to e to the power x, then we can write it is cos e to the power x into differentiation of e to the power x with respect to x. Done, sir. Now next, sir, sine differentiation is cos, whatever inside just copy as it is. Okay. Next, into differentiation of e to the power x is what, sir? E to the power x. So answer should be coming out like e to the power x cos e to the power x. Sir, most of the students are getting confused here. Sir, from the triangle e to the power x will take out and they will write e to the power 2x. Sir, from the function, trigonometric function, sine, cos or tan, if it is inside, it won't come out. Okay, inside value are triangular values, angular values, and outside values are linear values, sir. Don't ever multiply, right? Inside, see, if I'm taking just a example, don't take it negatively. If what you ate is inside your stomach, will be out, means inside only, it can't come out, right? Obviously it will come out, but the thing is here, it's, I'm basically in offline class, I'm making joke of it. It's inside the cos, inside the stomach of cos. Just imagine like this. It won't come out, sir. It will not multiply with this outside e to the power x. So, jokes apart, now focus on the question. You understood this? Hope you understood. It won't come out, sir. Okay. Next, sir, because this is going to be much helpful. So again, another example I am taking for your understanding, sir. Don't worry, you will understand. Wait. Differentiation of sine, let's say x square with respect to dx. Sir, simply what I did, I will do. Now shortcut you can follow. Sir, differentiation of sine x is what, sir? Cos. What I wrote, inside whatever it you write. And then differentiation of x square you will have to do, because it's not x, it's x square. So you will have to do x square differentiation, that is 2x. Now answer will be 2x cos x square. Hope you understood. Another example I am giving. Differentiation of, let's say, e to the power x square, sir, with respect to dx. Sir, it is differentiation of e power x power 2 it is. So what is this, sir? Sir, first differentiation of ex, e x square into, because it's not ex, sir, ex square it is. So what is the differentiation of x square? So it is going to be 2x. So answer is 2x e to the power x square. This is the answer, sir. Isn't it interesting, sir? Yes. So you can go through and you can understand what are the rules and what are the differential formulas and everything. So hope you understood, and in next video I will bring the application of differentiation, and then we will enter into trigonometry, sir. So let's end this session here itself and see you in the next video. Stay tuned and don't forget to like, share and comment, and hope most probably you might have clicked the bell icon also to get the latest videos to you quicker way. Thank you so much. See you.